let's talk about calculating logarithms. So the first way is to just use the fact that a logarithm is a way to explain exponents. If you see something like log base 3 of 9 equals what? A way to understand logarithms is to convert them to exponents. So this would be 3 to what power is 9? Well, 3 squared is 9, so that means log base 3 of 9 is 2. So if you think of a log in terms of an exponential function, then sometimes you can easily figure out what this number is. Similar idea here. If I think of this as an exponential, I'll have 2 to what number gives me 8. Well, 2 cubed is 8. So that means that log base 2 of 8 equals 3. That's not going to happen in class most of the time. Most of the time you're going to have crazy examples like this. 3 to what power equals 5? Well, 3 to the 1 power is 3. 3 squared is 9, so how do I get a 5 out of that? It's somewhere between 1 and 2. I don't want to have to guess and check. That is where the change of base formula comes into play. If you have log base a of x, you can type this into your calculator using a log button or a natural log button. This is the common log. Everyone should have a log button on your calculator. This is the natural log. Everyone should have a natural log button on your calculator. You can just pick which one of these fractions you want to use. So you write common log of x over common log of a, or natural log of x over natural log of a. It'll give you the same answer. Let's do those same two examples that we had earlier. That means if I want to calculate something like log base 3 of 5, I need to use change of base formula, and I'm going to write log over log. I always remember which one to put on top of my fraction, thinking through the 5 is physically higher up than the 3, so the 5 needs to be higher in my fraction. All right, let's type this into your calculator. Log 5, close your parentheses, divided by log 3. That means this is 1.46. If we wanted to go back to when we had converted it, you can always double check your answer. 3 to the 1.46 power should give you something close to 5. It's a little bit off because 1.46 is rounded. If I didn't want to use common logs there, I could have used natural logs, natural log of 5 over natural log of 3, and it would have given me the same answer. All right, so let's do one more example. If I wanted to calculate this using my calculator, it's going to be log over log, or natural log over natural log. The 3 is physically higher up than the subscript 7, so that reminds me it'll be 3 over 7. Log 3 divided by log 7 tells me that log base 7 of 3 is 0.56. If you wanted to use natural logs instead of common logs, it will give you the same answer. Natural log 3 divided by natural log of 7, it gives you the same answer. And some of you will be lucky enough to have an updated calculator where you can actually calculate these without having to use change of base. If you are one of those lucky people, you need to press the math button and scroll all the way down or up to A, log base. And in that case, I can type in my little 7, I can type in my 3, and it will give me the same exact answer that I got using change of base formula. So again, that was the math button. Scroll all the way down to A, the letter A, log base.